Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue my very popular series on great questions in web handling. Today I explain why you may want dual drives on laminators and how to do it reliably. Laminators have many web handling issues, above and beyond any product and process design development challenges. These include maintaining a super uniform nip across the width, path control, wrinkling, and much, much more. Here, we'll only focus on one. That is, the system is always highly over-constrained. The explanation is a bit complicated, so if you want more detail, you can find it in one of the modules of my award-winning Web 101 class. We will just summarize here that you have many more goals than you have knobs to achieve them. By goals, what I mean is things that are important to you. By knobs, I mean things that you can adjust that are relevant to the problems that you have. The problem we will focus on here is laminator curl. The adjustments that are always available are just two: the tension of ply A and the tension of ply B. Yes, in theory you could also adjust the modulus of the plies by choosing different materials, but that would require a product redesign that may not meet economic or customer expectations. So, while a list of factors is 4 for simple curl models, the reality is that you normally only allowed to adjust 2. Worse yet, only one knob, the tension of the lowest modulus ply, is the one that has any significant effect. However, the list of things that you might need to satisfy is much, much, much longer. First, because this is web handling, you can't do just anything with the tensions of the two plies. The two webs have a lot to say about what is too much or too little for tension. If that were all we're needed to accomplish, that would be simple. Trivial, in fact. Set the tension of A to, say, 10 to 25% of ply A's strength, and also set the tension of B to 10 to 25% of ply B's strength. But, and this is truly a big but, you almost always have other constraints in order to keep the customer happy. Just as two examples, your customer may want the web to not be excessively curled in 2 directions. If you've been counting, you notice that you have 4 goals, but only 2 available knobs to achieve them. That is way over-constrained already. Something like trying to solve 4 equations and 2 unknowns. A very unlikely math. But it gets worse. There are more problems that you might need to solve related to tensions or strains. Again, this is just an overview of the situation. See my Web 101 module for further detail to see why curl is nearly a ubiquitous problem in lamination. In short, you don't have nearly the number of knobs you need to keep everybody happy, and that includes the web and the customer. There are several options to deal with this over-constrained system that is explained in detail in my Web 101 class. In this short video, we will only focus on adding an extra knob, and you really need extra knobs, and that knob that we discuss here is dual drives. By that, I mean putting a motor on both rollers of the laminator. The first thing to note is that it is seldom possible or safe to gear rollers together, either electronically or mechanically. The reason is that it's nearly impossible to get the speed match close enough, and will be impossible if the web is thick or one of the rollers has a rubber cover. The net result is something must break. You either break loose in traction, or you break the gearing, or you break the web. The solution to adding tolerance to the drive design is to put one motor in speed control and the other in torque split mode. However, as I cautioned in Web20163w, meter on metal, the speed control drive must be a metal roller. The reason is that the effective diameter of the cover is not knowable, even if the physical diameter is. This is also covered in my Web 101 class. So, if you thought the previous discussion is complicated, I will only outline the results of dual drives because the details or math of what is happening inside the nip with a torque split is at the limit of our understanding. However, the net result is quite similar to dual drives on a center surface or two-drum winder. That is, you have an additional knob beyond tension. In this case, torque split to help reduce problems. I will close with just one more design admonition. That is, you need to have really, really big motors. That is because while most motors in a web line are working together, the intention here is that they fight each other to get the web handling work done. The bigger the fight, the bigger the range of effects of the torque split knob. So, if you have a single drive, it may need, for example, to be 1 kilowatt. However, if you use torque split on dual drives to get the work done, you may need to have two 2 kilowatt drives, or 4 times the connected horsepower. Fear not, my friends. The worst thing that can happen with dual drives is that they don't achieve what you want. An ever-present risk on any choice. In that case, you merely turn off one of the motors. Thank you so very much for allowing me to share my thoughts on great questions in web handling. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.